Hello guys, in this video I'm explaining about thread libraries. So before understanding thread libraries, if you have any doubts regarding threads, you can refer my video threading and multi-threading models. The link for that video is given below in the description section. So let me start with the explanation of thread libraries. First of all, before understanding what is a thread library, you should understand what is a library first. So library contains a built-in functions with code, right? For example, if you are writing a C program, there C library contains built-in functions like printf, scanf, along with the code of printf and scanf. Right? Why we have to store these library functions? Why we have to do like this? Because where this function contains the code, right? In a program, for me, I don't want to use that code. I just want to use the API. The code will be in the library. You don't want to use that code in the program. You just want to use the API. For example, see here, this is a simple program to print the message hello world. In this program, my library function printf, right, is present in the library along with the code. Printf code is in the library. But here I don't want to use that code. I just use the printf statement, that is printf API, to print the message hello world. I just want to use the library printf API here, printf statement here. Understanding guys? The code for that printf will be there in the library. You don't want to use that code, entire code, because the printf code will be of thousand or lakhs together of lines. But I don't want to use that much of code in my program, right? So what I can do means I can store that code in a library. Just I want to use that API, printf API. Just I can use that in my program and I can print my message hello world. Because the code is entirely stored in the library, you don't want to remember that. You just want to remember the API and you can use that in your program. So this is a library. But what is a thread library? Here this printf API allowed you to make your program simple, right? So in the same way, to create a thread or delete a thread, we can use the thread libraries where it will provide the APIs, just APIs like create or delete. We don't want to remember the coding part. We don't want to remember the coding part. The coding part will be there in the library. We have to just use the APIs like create and delete. Right? So let me see what is a thread library now. Understood guys? See, so thread library. A thread library provides the programmer an API for creating and managing threads. So far you have seen that the printf API is used for the printing the hello world statement. In the same way, to create the thread, it will provide APIs like create thread and delete thread. Right? The thread library provides the programmer the APIs, the create API or delete API or other APIs also. And one more important thing here, there are two primary ways of implementing a thread library. How to implement a thread library? There are two ways here to implement a thread library. There are two ways here. What is the first approach here? The first approach is to provide a library entirely in user space with no kernel support. Here, to create a library to store the code for the thread create for thread creating or thread deleting or other APIs also, you can use your user space with no kernel support. All code and data structure for the library will exist in the user space only, right? So and you can use only a local function call for this purpose and not a system call. But rather than this approach, you can use a second approach where a kernel level library is supported directly by the operating system. Understanding, guys? In this case, the code and data structure for the library exists in the kernel space, not in the user space. Here I am not using a function call, here I am using a system calls. Getting, guys? Understanding? So thread library can be implemented in two ways, either in a user library or in a kernel library. So you can go use any approach, but most of the cases uses kernel approach, that is second approach. Understanding? So next, so there are different thread libraries present here. Different thread libraries are there for different program or different operating system. For different operating system, you can use different thread libraries. The first library here, three types of thread libraries are there here. The POSIX, that is Pthreads, Windows 32, Java. These are the Java thread library, Windows 32 library, POSIX Pthread library, right? So POSIX can be used in mainly to create thread in Unix operating system, Linux. Windows 32 thread library mainly used in Windows system, right? Like that. So for different purpose, we have different thread libraries. There are three types: POSIX, Pthreads, Windows 32, and Java thread library. So Java thread library is mainly used to create thread in Java programming. So now we will see each thread library in detail. So what is Pthread? So Pthreads are the extension of POSIX standard. POSIX means Portable Operating System Interface. Here POSIX standards why we created means to mainly to achieve portability. Portability means, you know, that once you write the program in one system, you can use the same program in other system also without any changes. So portability, POSIX mainly invented to achieve portability. So mainly to use this Pthreads, we can use this mainly to use this Pthreads. We have to use this in Unix operating systems. And one more important thing, Pthreads can be implemented either in a user or kernel level library. Understanding, guys? So Pthread can be implemented either a user level or kernel level library. The Windows 32 library is a kernel level library available on Windows system. The Java API allow thread creation and management directly in Java programs. I already told you, right? So understanding, guys? So Pthreads mainly it is implemented either in a user or kernel level library, mainly used in Linux operating system. The Windows 32 thread library is used in Windows systems. It is a kernel level library. Java is mainly used in Java programs. Directly you can use Java thread APIs in Java programs. Now we will take one example program here. Then we are going to explain the each thread libraries in detail. I will take an example program. Here we design a multi-threaded program here. That program performs the summation of a non-negative integer. Summation means I will explain in the next slide. So this program, what is the task of this example program? What it does? This program, it is a multi-threaded program. We will use multiple threads in this program, and this program does the summation of the integer, right, using a separate thread function here. So using this program, we will try to understand each thread APIs in detail. That is each thread libraries in detail. Same program, same example program used in Pthreads also, used in Java also, used in the Windows API also. Understanding, guys? So what is this program? now we will understand the main intention of this program here. So here this program needs to calculate the summation. Summation means, for example, here if you give the value of n as 5, then it will find the summation. The summation will be like this. So 5 is my value, right? So 0 plus 1 plus 2 plus 3 plus 4 plus 5. It will do the sum of all the values from 0 to 5. That is the summation. The value will be 15. The value will be 15. So I am going to write the program to do the summation. Here my example program contains the value 5. You can calculate the summation for other values also, but here I am taking an example for n as 5. Understanding, guys? My program is to calculate the summation by taking the input as an integer. Here it is, in this example I am considering 5. Taking 5 as the integer, it will calculate the summation, then that summation value will be 15. So the final output of my program will be what? 15. Let me see this now. So before that, we will try to understand some things related to, some important things related to Pthreads here. So what is a Pthread here? Pthread refers to the POSIX standard, right, defining an API for thread creation and synchronization. Yes, so mainly Pthreads are used to, Pthread libraries are used to create three threads. It is going to provide the API for creating the threads, right? And here the main important thing here, it is going to give a API, just API, create API, delete API, like that, for creating a thread, create thread, delete thread, like that. But user can write his own program using this API. Operating system designers may implement the specification in any way they wish. Means I can write the program in a different way, others can write a program in a different way, but whatever the program, whatever the logic you are going to use, but the API is what you are going to create, that create thread, delete thread, that is not going to change, right? So I am trying to say that. So you can use the same API, but your program logic may be different, right? Understood, guys? Right? So you can see here create thread. So here see the highlighter here, create thread function is there, right? API is there, right? This is same for every program. Even I have to use the same API, others have to use the same API, but the logic what I have used here, this logic can be changed, depends on the designer, right, guys? And one more important thing, Pthread is already implemented in so many specifications like Solaris, Linux, Mac OS X, etc. I told you, right? Pthreads are mainly for Linux operating system. Now, so I told you, right, the program to calculate the summation. So I will take that program as example and I will explain this program in detail. So this is the program. So this is the program this is a multi-threaded program to create the summation of a integer. If your input will be an integer here, taking the input, it will calculate the summation of that. For in this example, what is the value of my integer? 5. So what should be the output here? 15. So we will understand this program step by step now. See here. Before understanding the program, you need to understand the what is argc and argv, because this argc and argv is used in the main function in this program. First you have to understand what is argc and the argv. See here. So argc is what? Argc is a command line argument. So this argc and argv we will use in the program, right? We will use this in the program. That's why it is very important for you to understand what is argc and argv. So argc is a command line argument. Argv is an array to store the command line argument. You can see here, this is the argc. Argv is an array to store the command line argument. in this program, you know that what is the value of the input here. 5 is my value of my input here. So my input is going to store, my command is 5, right? That will be given through command line argument, that is argc, and that argument is going to be stored in a argv, that is array. Here 5 is my input, right? So it will be stored in the array. Argv starts with 1. Remember, you know that other arrays start indexing, array indexing, you know that, right? Array always starts with 0, but argv array starts with 1. Remember that, don't forget that. Argv array starts with 1. So the input 5 will be stored in the position 1 here. Understanding, guys? For example, n is equal to 5 is nothing but it's only one argument, right? That is 5 is that's why 5 is stored in the space argv of 1 here. But here, suppose you are giving a floating point number 1.2. How a 1.2 will be stored here? See, you can see here 1 is stored in the argv of 1, point is stored in the argv of 2, 2 is stored in the argv of 3. Getting, guys? So your command will be stored in the argv array like this. This is very important, you have to know this. So argc is a command line argument. Your command argument, that is your input, will be stored in the array argv. Argv index starts with 1. Here in this example, my example, I am giving only the input 5, that will be stored in the location argv of, that will be stored in the location argv of 1. Suppose if you are giving a floating point number, it will be stored like this. It uses 3 slots, but here it uses going to use only 1 slot here, that is 5. So now we will move into the program. We will understand the program step by step. So for each library, the same program we will use, but the logic, the program syntax will be different. That's all. Logic, even the logic will also vary little bit. So see here. So if you are using if you are writing a multi-threaded program in a POSIX environment or in a pthread, if you are using pthread, this header file is a must, right, guys? So this program I am explaining, the same program, this program I am explaining, but step by step I am explaining. Here if you are writing, if you are using pthread library, you have to use the header file pthread.h. This is compulsory. So this is the first step. You have to write a header file pthread.h along with the stdio.h. What is the next thing? So here you can use, you can see here in this program I am using a variable sum. Sum is a global variable. Here sum is going to store the result. For example, my input is 5, the result is 15. The result 15 will be stored in the variable sum. This is a global variable. Global variable means here in this program, remember guys, this is a multi-threaded program, right? This is a multi-threaded program. Here I am creating 2 threads. Remember, how many threads? 2 threads. Multiple threads, 2 threads. So that's why this sum variable is there, right? This should be shared between 2 threads. 2 threads will use the same sum value, that is 50. Now we will see what happens now. Now we declared the sum variable here. Now, so when the program begins, a single thread of controls begins in main. So see here, you can see here, this is the parent thread here. So this is the runner. Actually runner program, this runner program is a child thread. It is not created now, but the first thread holds the pointer to the runner thread. Understanding, guys? Runner thread is not created now. It is not created now, but the first thread, that is parent thread, holds the pointer to that runner thread. What is the use of it? Why? Because when a runner thread is created, so the control should be transferred from this parent thread to the child thread. Why? Those things we will see now. So but So far you should understand that here the parent thread is created here. This is the parent thread, right? When the program begins, the control will be in this thread. Remember, the control will be in this thread. You can see here. So for this thread, the whatever the parent thread that created, for that thread, the thread ID will be stored in this variable. Not only the thread thread identifier will be stored, along with some attributes also stored. Attributes like for each thread, you know that some set of attributes will be there, including stack size, scheduling information. Those things will be automatically stored in this attribute. You don't want to worry about those things. Automatically, when a parent thread is created, the thread ID for that parent thread and the attribute for that parent thread will be automatically created. Understood, guys? So far what we have done, you use a header library pthread here, pthread library, header function, header file we have used here, header file pthread. Next we declared a variable sum that is used by both the threads. Now I am creating a parent thread here. This parent thread holds the pointer to the child process. The child process is called as runner. It is not created yet. We will create now. So in the coming slides we will see that. But this parent thread holds the pointer. Now the control is in the parent thread. Now once the parent thread is created, the thread ID and the attributes of the thread will be stored here in the main function. argc and argv I have explained here, right? So you can see here why the pointer I have used in argv means, you can see here the pointer from argc to argv. Next, now these two statements is for checking some error conditions. What are the errors that may arise in this program? For example, the first statement, this first statement here is right. This statement is for error checking, right? It checks for using the integer value. That means what is the input I have to give to this program? My input value is 5. I should not give a floating point value. My input value should be 5. It should not be 5.0. If you are giving a floating point value, then it is an error. This will display an error and it will display the message that you should enter the integer value. So in my program I need to enter integer value. So this if you enter floating point value, this will show the error. Now what is ATO? That is its conversion. I am converting from alphabet to integer. Because you can see there my input value is n, right? But n stores the integer value 5. That's why it should be converted to integer. My input should be in integer format. That's why I am using alphabet to integer. So here argv1 less than 0. Here the next statement checks for what? It checks for that at least one argument should be there. You should give at least one input. So input can't be empty here. If there is an if you don't give the input, then it will display that argument can't be blank. You have to give at least one input. Getting, guys? So it will check for the error condition. So far, so here we have to create two threads, right? So we created only the parent thread here. Just it holds the pointer to the child thread. Now we are going to create the child thread. The parent thread holds the pointer to the child thread. Actual calculation of the summation will be done in the child thread. So let me see this now. Now see here. So here I am going to create the child thread here. You can see here. So for this what I am doing here, I am creating the child thread here. You can see here pthread create. So to create the thread I need thread ID attribute. I told you For once you create the thread, this values will be automatically assigned to that particular thread. This what is the name for that child thread? Runner. The name also I am giving to the child thread. So what is the name here? The runner. So that's why the pointer to the runner, I am holding the pointer to the child thread runner. This is the parent thread. Now I am creating the child thread here. So that is the runner. Actual thread is now I am creating now. The parent thread holds only the pointer. Argv of 1. Why argv of 1 we are using? Because the input is present in argv of 1. The phi is present in argv of 1. That's why I am specifying the argument also. Understanding, guys? Now once the thread is created, once this child thread is created, the control is transferred. The control is transferred from the parent child, the parent process, the control is transferred from the parent process to the function, this function that is in the child process. You can see here a separate thread is created with the pthread create function call. In addition to passing the thread identifier, the attributes of the thread, we also pass the name of the function. What is the name of the function here? Runner. So understanding, guys? So what is the input we are passing? 5 to this child thread. This child thread uses the function. What is that? This is the runner function. This what is the child thread we have created now? This child thread is using the runner function. You can see here. That's why I have specified the name runner here. So it is this child thread is using the function runner to create the summation. Now the control is transferred from this parent. Now the control is transferred from this parent to this function that is in the child process. Understanding, guys? How it is going to calculate the summation now? Let me see this. It is a very simple thing. So what is my value? Input value here will be 0 and upper value will be what? 5, because up to 5 it has to calculate the summation. So it will start from 1, because 0 if you add 0 to any value, it will be there is no change in the value, right? That's why. So it will start from 1 here up to 5. It will calculate 1, 2, 3. We will see this, how it will do this. See here. So see here, it will start from 1. So what will be the command in this function? Sum is equal to sum plus I. Sum is equal to sum plus I. So first 0 plus 1. Sum will be initial value. What is the sum initial value? You can see here the sum initial value is 0. So that's why 0 plus 1. So 0 plus 1, 1. Next sum value will become 1. 1 plus 1, 2. Again sum value will become 2. 2 plus 1, 3. 3 plus 1, 4. Lastly 4 plus 1, 5. So if you add all this, what will be the result? 15. The result will be 15. Now it will stop. The upper will stop now, because what is the condition here? Lesser than or equal to upper. Upper value is what? 5. So now my I value is 5. It is equal to 5 also. I value is also equal to upper value, that is 5. That's why it will stop. Understanding, guys? So if you have any doubts, please post your doubts in the comment section, right? So now one more important thing here, we have used pthread join. Why we use this? Here the parent process has to wait until the child process finish the execution, because the child process contains the runner function, and this runner function has to be executed, right? The control is now with the child. The control is now with the child. So the parent here, this parent has to wait until the child executes, until the child calculates the value. Once the child calculates the value, here that's why I used pthread join. Here we have to use pthread join because we have to wait. Now we will see this in detail. At this point the program has two threads, you know that, the parent thread and the child thread. The summation is carried out in the runner function. This runner function, the summation is carried out in the runner function. After creating the summation thread, the parent thread will wait for it to complete. Obviously I told you, right? So this parent thread has to wait until this child process, until the child performs the operation. How it will do? Pthread join function we will use here. Parent has to wait until the child finishes. Next, the summation thread will complete when it calls the function pthread exit 0. Now once the child executed, once the execution is completed from the child process, we can exit here, we can exit. But parent has to wait until the child finishes the execution. Now we can exit here. So once the thread is executed, the parent thread, what it will do means, it will take the value 15 from the child thread and it will display the value 15. Which one will display? Remember guys, child will only calculate this value. Child will only calculate the value 15 here. This child will only calculate this value, but the parent, now the parent thread has to display that value. So the child thread has to calculate the value. Now the parent thread has to display that value in the output that will be stored in the some variable. Understanding guys? So parent thread has to display it, but child thread has to calculate it. So let me brief this. See here. So in this program we used a header file pthread. So we use a variable sum. Next we are creating a two threads here, the parent thread and a child thread. First we are creating a parent thread here. This parent thread holds the pointer to the child thread. The name of the child thread is what? Runner. Now we have not created so far, but we will create once the child is created, we can start this execution. So now, so main function, what we will do means, once the parent is created, the thread ID of the parent and the attribute of that parent thread will be automatically stored here. Now after that we will check for the error condition. That means we should give only the integer input. We can't give the floating point input. Here we have to check that at least one input should be there. Less than input can't be empty. We have to check for that condition. Now, so I told you, right, the pointer will be in the runner. Now that pointer, the control is in the runner, that is in the parent, but child is not created yet. Now we have to create the child. So I am going to create the child here. This child contains a function that is a summation function, where the summation function is going to create the summation of the value 5, that is 15. So once the value is calculated, so this value of the child, that is 15, will be passed to the parent, because the parent holds the pointer. Now the control is passed from child to the parent. Once the child is completed the execution, we have to wait that parent has to wait. Using a join method we will wait that, right? Once we have to wait until the child finishes the execution. Parent has to wait, so it will wait until the child finishes. So once the child finishes, we can exit here. But so after calculating the result, the child has to pass that control to the parent. The parent will display the result. This parent will display the result 15. The 15 will be displayed here. Understand guys? One thread is to display the result, one thread is to calculate the summation. Summation will be calculated in child. The result will be displayed by parent. So I hope you understood the concept. Now what we will do means, we will take the same program, that is to calculate the summation of the integer 5, but we will write the same program in Windows 32 API, using Windows 32 API. This one is using Pthread APIs to create a child, right? Here the only one difference is the entire thing is same here, the same program we are using here, but the difference is what? Instead of Pthread library, we are using Windows 32 library. So same program, same thing it will do, but APIs are different. Now we will see this program in detail. Now, so you know that to do the calculation in a Pthread program, in a Pthread library, what is the header file I have used there? That is pthread.h. But if you are using a window API, the header file you have to use here is windows.h. You can see here the header file is changed here because the to create a thread, the API I am using is different here, that is Windows. That's why the header file windows.h has to be used here. So you can see here, so there also I used a variable sum, right? Here it is a little bit different thing. Here this sum variable is an unsigned 32-bit integer because this sum can hold the integer value. There I used a variable sum. Here also I am using the same variable sum, but it is different, right? It is a simple variable what we have used in the Pthread. Here it is a word data type, and it can contain 32-bit integer. Mainly this variable is used to store the output. Getting, guys? Now, so you can see here, here this is the summation function, mainly to create the summation. Here what is my input value? 5, so it will create the summation 5. So here also we are using the same summation function, but the very important thing you have to remember here means, so summation will be carried out by the separate thread. You can see here the summation function is passed a pointer to a void which is LP void. So this contains a pointer. LP void is a pointer. This summation function contains the pointer to the parent child, because once the summation is calculated here in the child process, that the result should be passed to the parent process, right? That's why I am using a pointer. Why I am using means this pointer is responsible for passing this result to the parent process. That's why I am using a pointer LP void. Understanding, guys? So here how this will be how the summation will be calculated means the same logic here. Again you can see here I is equal to 0, I less than or equal to upper. So again sum is equal to sum plus I, same logic it will calculate. Same logic also used here. It will calculate the summation here. Now you understood, right? So but the only one difference here is the LP void pointer. The LP void pointer we are using, the LP void pointer why we are using means we have to pass this function value to the parent process, right? That's why. Now we will see this. So this is the parent process I am creating here. That's why this parent process ID, this parent process will have the ID, you know that, right? So handle, mainly this handle is used for the parent process. This handle is used by the parent process, and this LP void is having the pointer, right? This pointer is going to point to the thread handle, because you know that here also we are using two threads. This is the parent thread. The thread handle is the parent thread here. And this is the summation function that is used by the child process. Now we have not created child process yet. So this function is used by the child process. Once the child process use this summation, the result needs to be get back to this parent, right? this parent process, right? That's why I'm using the pointer here. Now, so now I created the parent here. The thread ID is also automatically assigned the parent. Again, I'm creating error conditions here. I'm checking for errors. The same thing here. Here also floating point number can't be used, and argument can't be 0. At least one input should be there. So same thing here, no changes. Here also I'm creating the parent process. Here also I'm using the same summation function. Here also I'm using 2 threads only. Now you can see here thread handle create thread. Here you are creating the child process. So once the here also the thread handle, you can see here, so once the summation, you can see here the summation function is also used. The summation function is also used by the child process. Which summation function? The summation function. The summation function is used by the child process to calculate the summations. You can see here. Once the child process is created, it will use the summation function and it will pass that value to the parent process. How it will pass means, you can see here the thread handle is there. By using the thread handle, it can pass the result of the summation to the parent process. So you can see here how it will calculate means, so it will, you know that, right? Default security attributes, these things are very automatic. Stack size, these things will be automatically created. Thread ID also. So once the thread is created, you can see there the summation value. This summation value can be passed to the summation value can be calculated by the child process. So once it is calculated, you can see here the thread handle should not be null. That means child should pass the calculated summation value to the parent. So but parent has to wait until the child completes the execution. Once the execution is completed, you can see here, you can close the handle and the parent process can return the value of the sum. Getting, guys? Understood? So here also I'm using create thread function. This attributes, all those things will be size of the stack, flag, these things, suspended state, flag states will be setted automatically, and here we use the default values, automatically calculate values for the attributes. Once the summation thread is created, the parent must wait for it to complete before outputting the value of the sum. This sum output will be displayed by whom? The parent. The sum output will be displayed by the parent. You can see the parent, because you can pass the thread handle to the parent. Once the child is going to complete the execution, we can exit the child can exit, right? So it can close the handle, right? So here you can see here, wait for the single object. There to wait, what I used join method, but here to wait, I'm using a command wait for the single object. In POSIX I used which one? Join, right? Sorry, here, right? Pthread join. This is to wait. Child process has to wait. Sorry, parent process has to wait until the child finishes the execution. So join I used, but here in Windows, what is the command I'm using? I'm using wait for single object. Here parent has to wait until the child finishes the execution. Once the execution completes, you can close the handle, right? So understood, guys? So here also same thing, 2 threads I used. Parent thread wants to display the result. My result is 15 here. Child thread is used to calculate the summation. Let me brief quickly. So here I have to use Windows header file. Here I am using a sum variable here also, but the format is different. Is unsigned 32-bit integer. Here I'm using a summation function. This summation function is used by the child process. You can see here this summation function is used by the child process. So to calculate the summation value, once the summation is value is calculated, this value should be passed to the parent process. You can see here the thread handle. This is the thread handle for the parent process. The summation value will be passed here. So here you can see here the child has to execute, the parent has to wait. Here this has to wait until the child finishes the execution, right? So that's why I'm using a command wait for single object command here. Understanding, guys? So these are the two error conditions. These are the two error conditions. You know that, right? Same error condition. Floating point can't be used. Floating point number can't be used, and only one input should be there. Zero input you can't give, right? So lastly, if child is executed completely, you can close the handle and you can exit it, and the output will be displayed by which thread? Parent thread. And the summation calculation is done by which thread? Child thread. Getting, guys? Now same program, but the APIs used here is different because I am using a Java API. So far we discussed two APIs now, Pthread API and the Windows 32 API. Now we are using a Java thread APIs. The same program, nothing will be changed. Well, a little bit logic and some APIs will change here. So let me see this program here. So you can see here. So in the previous two programs I was using a global variable sum, right? The sum variable can be used by parent also. The sum variable can be used by child also, right? So both the threads, a parent thread and a child thread, both can use the same variable, right? Sum, they can access it, right? Because it was a global variable. But here in Java this is not possible. Globally you can't use the variable here. That's why you are using a shared object here, sum. You are using a shared object, and you are using commands get sum and set sum. So you are using a methods, two methods you are using, get sum and set sum, because you have to fetch the value of the sum, right? In the previous example you can directly use that because it's a global variable, but in Java it's not a case. So to use the sum variable, the sum value 15, to use this to display in the output, you have to use these two methods. What are those methods? Get sum method and set sum method. So this is the code for that. So next, so here also you can see here in Java, here also we are using the same summation function only, but in Java this summation function is implemented as a runnable interface. You can see here how to create a runnable interface. There run, right? In previous example run method we used, right? Here the runnable interface can be created here. You can see here the runnable interface is created using these commands. And when a class implements runnable, it must define a run method. So for runnable interface you need to use run method. You can see the highlighter here. We have to use the run method in the runnable interface. So getting, guys, run method. So this run method is going to run as a separate thread, and it is going to calculate the sum value. Same logic here, same logic. Int I is equal to 0, again it will start the same logic here. This logic will be applied here. Again I will be starts from 0, but 0 plus 1, 1, 1 plus 1, up to 5 it will execute. Same logic, I is equal to 1, right? So same logic here also, the same logic will be carried out here, right? So you can see here, once the sum value is calculated, you are setting that sum value here. You are setting that sum value to the sum variable, because it is not a global variable, right? Understanding, guys? Here also I'm applying the same logic, but the main difference here is I'm I'm constructing the runnable interface here. I'm constructing the runnable interface here. So in the runnable interface, I'm using the method run. There, the run method is going to calculate the summation. Understanding, guys? So now you can see here. Now, so far I have not created the child process, right? So far I have not created the child process. Only I have used a run method to calculate the function, right? So this function needs to be utilized by the child process. So let me see that. See here. So void message, you can see here. Here also the two statements, error checking is used, mainly the same thing. That is floating point number can't be used, and zero input can't be there. So you can see here you are creating a object here, some object. So here you can create how you are creating the sum object means by creating the thread. You can see here you are creating the thread here, and you are sharing the sum object. The child process is going to share that sum object that is calculated in the run method, right? Here also I'm using two threads, same two threads. So you can see here sum is equal to, when the summation program runs, two threads are created by the JVM. The first is the parent thread, which starts execution in the main method. You can see here in the main method. So in the main method it starts executing. So parent integer argc is, this is the condition, sorry. You can see here create the object. This parent will start executing. So the second thread is created when the start method on the thread object is invoked. So start, here you can see here the start method is invoked. The start method, what it will do means it will run this run method and it will calculate the summation. It will run this run method and calculate the summation. Which one? This is start method, this is the second thread, and this is the first thread. This is sum object, this is the sum object is there, right? This is the first thread, and this is the start object is there, right? So this is the child thread. This is sum, this is child. So understanding, guys, start, once the start method is used, this is the start method. What it will do means it will use this run method to calculate the value of the summation, and it will pass that value of the summation, this child thread start, pass the value of the summation to the object. Which one? Sum object, which is the parent thread, to the sum object, which is the parent thread. And here also you can observe one thing: child has to wait, and child has to execute, and parent has to wait. Here also child, the start object has to be completed the execution. So start, once it completes the execution, it can go out. You can see here catch interrupt exception. So once the interrupt exception is generated, you can come out of the program. But before that, you can see here I used join, right? So join, why I am using means here parent has to wait until the child start completes. So once the, that's why I am using join here. Once the child thread start completes, using this run method, it calculated the summation, right? You can come out of the program using the interrupt exception, by generating the interrupt exception. Once after that the child is executed, right? After the child is executed, you can see here the summation value. The summation value needs to be displayed. How it will be displayed? By using the sum object. You can see here the sum object is created by whom? The parent process, and it will take that sum object value and it will use this in the sum variable, this sum, and it will display that. Who will display that? Parent. This sum object will display that. Who will calculate the summation? Start. This is the thread start will do the summation thing. Understanding, guys? The child thread begins execution in the run method. You know that, right? I already told you this one to calculate the summation. The summation class, after outputting the value of the summation, the thread terminates, obviously. So once the summation value is calculated, you can terminate. How you are going to terminate? Using this interrupt exception. Using this interrupt exception. So join, why I am using? join I am using because here this start has to finish the execution. So the parent sum object has to wait until the start, that is child thread, finishes the execution. Here the parent is sum object and the child is start. Getting, guys? Any doubts? If you have any doubts, please post your doubts in the comment section below. Right, guys? So let me brief quickly. So here the same program, we are taking the summation program. The main difference here is, here we are not using a global variable, we are using a two methods here, get sum and set sum. So here summation, you can see here I'm using here I'm implementing a runnable interface. This runnable interface contains a method called run here. This run is responsible for calculating the summation. So here what is the output for the summation? 15. That will be calculated by this run method. But here what I am doing means I am creating a parent thread here, sum object. This is the parent thread. So that is start is the child object. You can see here start. It is start. What it will do means it will use the run method. Once the child thread start is created, it will use the run method to create the summation value. So after that, it will pass the value to the parent, that is sum object. It will take that calculated sum, new sum. It will take that calculated sum, new sum, and it will display in the output by storing in the sum variable. Right? So but here along with that, along with creating the parent process, along with creating the parent child thread and the parent thread, what we are doing means we are using a join function here. So why we are using a join function means because we have the child, once the child finishes the execution, the parent has to wait until the child finishes the execution. Once the child finishes the execution, the parent thread can stop, right? That's why join means we have to wait until the child finishes the execution. You can see here, once the child is calculated the value, once the parent took the new sum value and it is displayed here, you can come out of the program. How you can come out of the program means by generating the interrupt exception. That means interrupt you have to generate and you have to come out of the program. So that's it, guys. So any doubts? Okay, if you have any doubts, please post your doubts in the below comment section. So, thank you for watching the video. Please don't forget to subscribe to my channel. Please click the bell icon to get the notifications, and don't forget to like and share.